Here we are at Midwestern State University Engineering. We are at the Thermofluids Lab. So we'll go in here and we'll look at some different safety features. This is our chemical area. We have an MSDS book. Kind of overall layout of our lab. We do have a fire extinguisher and a eye wash station here on the wall. And now we'll have Dr. El-Sharafi talk about some of the labs that the students use.
Okay, we have a different labs that we are use. The student they have to measure, different labs such as the viscosity of liquid. And they have to do that during the experiment. We use the liquid, we call this liquid glycerin. And the student also, they drop some spheres, they have to know the specific weight of this sphere. And, that we have a different type of the spheres, and they have, to measure the viscosity, and also they have to measure the dynamic viscosity of the liquid. And they have also to calculate the Reynolds numbers. That's the first experiment. The second experiment that we use the hydrostatic thrust on the plane surface. We have, for the plane surface, we have a submerged plates, and these submerged plates, and we have to do two experiments. One experiment when the plate is submerged, another one when the plate is semi-submerged. And the student, they have to calculate the force which is in the center of the containers, and of course they have to measure the dimensions from different points, and also they have to take the thickness of the plates, and they have to measure the momentum. And we use a different angle. We start with a 0 angle, and then we have 15, and also we have 30 angles. And to control these positions, students, they have to put some of those weights, and they make sure they weight everything that they add to the experiment, because we need to know how much weight that we add to have the positions of the container. That's we call it the pressure thrust. The third experiment that we do here, it's about calibrations of the Borden pressure gauge. We have the Borden pressure gauge here. That's a Borden pressure gauge. It's connected from the back by hose. And this hose, we make sure we use the piston here. We have a piston. We have to weight this piston, and there is a hose is connected to the gauge from here. We have to fill it with the water, and we need to make sure there's no bubbles, there's no gas. Okay, and then we put the piston, and we put some of those Newton. This is weight Newton, and then we measure the pressure in the gauge, and also we know how much how much Newton that we put in the piston here, and of course the weight divided by the cross-section area, we will get a pressure. And then we have to draw between the calibrations, the pressure that we got from the gauge, and also the true pressure that we calculate. If the experiment is good, we should get a straight line relationship. Okay, number 4, that's flow through the venturimeter. Flow through the venturimeter, which is this one here. Actually, this experiment, we know the diameter for the each manometer, it's connected for each point here. We have point A to point L, and we have the cross-section area, and also we have the diameter. The fluid flows come through the hose here. It's go back to the water tank. We use this water tank, for all of our experiment that we are using fluid flow. And the student, they have to measure the H1 and H2. They are pressures, that's we got it from the manometer level here. this is H1, and we have H2. That's, you know, that's the pressure drop or the pressure loss around the Venturi meter. And the student, they have to do some calculations. Of course, we use the different flow rates. We have the flow meter here. It can measure the flow, you know, which is we can control it from we have valve. On the other side, we have valve, and also we have a pump. You know, we have to turn on the pump, and we control the speed by the valve. Okay, the fifth experiment, actually it's similar to the number 4, but here we have a different, you know, types of measurement that we have to do through, you know, through the fluid flow inside, you know, the flow measurement. We have orifice. We use it. We have orifice. We have restrictions of the flow. We have Venturi meter. We have elbow, and we have rotometers. And each point here is connected to the manometer, and then we can measure the head pressure, and we can measure the height of the manometers through, you know, different points, and those can give us an idea about the pressure loss in our system. And this we call it the fluid flow measurement. And the same things the student, they have to do like several experiments with different flow rate, and they have to measure like the pressure loss in the flow measurement system. Number 6, which is the impact of the jet. Impact of the jet, we have the fluid that's come from the bottom and it's flowed to the top, and we have several cups. You know, when the fluid is come from the bottom to the top, there is a velocity 1 and there is a velocity 2, and that velocity depends to the shape of the cups. And of course we need to use the weight here, and this force, this is provide the force, weight is provide force on the water jet, you know, and then we have, you know, we have to make sure that this weight, it's the right weight, because we need to have a balance. Okay, and we use it a different shape. I think we use it a 30-degree angle cups, and also we use it I think we use the cup that conical one, and we have like 3 or 4 different shape of the cups. Number 7, that's the fluid through an orifice. Fluid through an orifice, in the bottom here, as you can see, we use it a different orifice. We use it a circle orifice, we use a triangular orifice, and we use it a square orifice. We use it a different shape. And what we have to do here, we have to use the fluid that's come from the bottom, and then we have to the fluid flow to the top, and also we have to measure like the water jet cross section area by the beta tube. We use the beta tube to measure the cross section area, you know, for the water jet. We have to measure the outside diameter and inside diameter, and that's give us a constant factor, which is which is going to be the ratio between the cross-section area of the water jet to the cross-section area of the orifice. And the same things, this is also needed to find out, you know, the different force and compare those the fluid through the orifice for different type of for different type of orifice, and the student, they have to find out the different, you know, for the water jet when they use a different type of orifice. Also we have experiment that we call it, you know, the forces for task. And the forces for task, you know, the student here, they have to understand, you know, the phenomena of the rotations of the water. And this is, in this experiment, student, they can see the tornado of, the tornado, and also they have to figure out the piezometric head, and they have to find the piezometric head and how it is gonna affected by the speed, because we use the speed, rotations, and also they have to measure, like there's a piezometric head, and there's a head that's small h, and we have a big h, which is distributed like the water level, and also the piezometric head, and they have to go like to the right, and they have to go to the right, and they have to go to the left, and they have to summarize their result, and finally they need to submit report for all of those experiments. And the last one, it's in the fluid in the energy lab. That's about the Aero Lab substance wind tunnel. And for that lab wind tunnel, the purpose of that lab, it's not in this room, it's in the other room. We can show it to you later. It's we control, we start speeding the wind tunnel with a constant speed, and then we have to use like in wing, and wing it has a different point. The airplane, it's lifted by the pressure, and that's we have to take, we have a simulated wing. We have different point in that wing connected by the hoses, and those hoses can give us an idea about the pressures connected to the small water tanks. It work like a manometers, and giving us an idea about the pressure distributed on different points in the wing. And that's the last lab.